Hey, it's Pop Goes the Stack, the show that dissects emerging tech with all the finesse of a root cause analysis after a 3 a.m. pager alert. I am Lori McVitie, and we're going to get post-mortem today. We've got our co-host, Joel Moses. Hey, Joel.
Hello, good to be
And
here.
today, because we're talking about context windows, we've got Vishal Murgai, who is a senior architect in our AI Center of Excellence. That's a mouthful. He focuses on AI and data science. Welcome, Vishal.
Glad to be here. Thank you.
Awesome. Well, this episode is brought to you by Anthropic, as it often is. They lobbed a 1,000,000 token grenade into the Copilot coding wars. And suddenly, every startup hawking clever context management looked like it was selling floppy disks in a cloud world. Very bad. But what's really at stake here is context, right? The running memory of a model that it can see in a single shot. So it's the difference between feeding a model a sentence versus handing it your entire code base or compliance manual and customer history all at one time. Now, as enterprises scale out AI and start building it themselves, and we know they are, 80% are running inference themselves, which means they have to manage context. We wanted to bring to light some of the issues, challenges. What should they be looking for? And, how can they understand what is context anyway, since most of it's hidden behind chat
Yeah,
UIs today for most users. So
yeah.
let's get into it.
Yeah, now Anthropic announced an increase in what's called the context window for its popular Claude Sonnet 4 foundational model back in the middle of August. This was pre GPT-5 release. And this increase in the context window was not just an incremental one. It doubled from 500,000 to 1 million tokens, which is a pretty big jump in one go. Vishal, if you could explain to our audience what a context window is and why a large context window is important.
Yeah, so like the that's definition of context window is the kind of the maximum span of text measured in terms of tokens that a large language model can process at a time at once, right? Right. Even every prompt, every document, the conversation history, and the instructions that fit into this single window, right? That's kind of how much you can fit in. Like it used to be like 512, 1K when we started all this like years ago. Now it's like 1 million more, pretty go more, right? So that's kind of, and token is kind of chunk of text, usually 3-4 characters, just for an audience to understand this. About 1/3 of word typically. So 100 tokens is about 75 words typically. That's what I've seen from my experience, right? And the 1 million window now roughly is about 700 to 750K words, right? It's a
Yeah.
huge chunk there. So multiple books worth of data essentially, right?
Okay.
And because the model doesn't have infinite memory, so it's only, I would say, it sees a text in the current window, right? So that's kind of how it is. Old text that falls out, old text falls outside is forgotten, basically. Anything which is outside this window is forgotten. That's kind of the definition of this, right? So
I see.
it's a working memory in human brain, essentially, if you want to analogy of that, right?
So what approach did people use prior to the availability of larger context windows? I mean, the data that people ask of these models can sometimes exceed the context window parameters. And so what approaches did they commonly use to try to analyze all the data that they needed to analyze?
So before all this came into picture, like before this context, so we used to do chunking, right? We will basically, it's a great question to start all this, right? So it's before we had million tokens, people still needed the models to kind of reason over big documents and all, right? So, but the model simply, model will do essentially, we had to do, the user has to do chunking and retrieval, RAG models, I would call it, right? So we take a big document, split into small overlapping places like 500 to 1,000 words, right? And tokens, right? And create vector embeddings for each of those, essentially break it down, create vector embeddings for each of those chunks and store them in a database, right? At query time, retrieve only the top n most relevant chunks, right? That's kind of how we would do before, right? So that's how it was done before, chunking and then retrieval or that kind of thing right before.
That kind of explains why sometimes the AI forgets what you said because it only pulls the top X or something dropped out of the context window because it became too full and it it forgot your name and calls you something else, those kinds of issues, right? It can forget important information because it gets pushed out or it's just not as relevant when it did the actual embeddings.
Right.
Now, it sounds to me like now that we don't have to chunk necessarily, now that ever larger context windows are available, that has an architectural design effect on AI applications, doesn't it?
Yes.
What are some of those?
So I think it doesn't, okay, it helps a lot, all these large token windows, right, context windows. But now when you're talking of challenges, it's governance at scale, right? When when you can dump entire document or entire code archive into, you risk your sensitive regulatory information or irrelevant data to go into the model, right? So that's kind of one example, governance at scale now, because talking of huge data here, right? Cost of it, and because if I'm a user, right, I'll say, okay, I am lazy, I dump everything into this, this LLM, and then let it figure out, right? Increase the cost and token efficiency again, right? Because you had to incur the cost there when you're sending something to it, right? And trajectory and ordering, right? Model has no inbuilt roadmap on how this whole big chunk that you, so we see the concept of trajectory that was introduced recently, right? With all these things that, that you get a roadmap, a guideline kind of thing, how to, if you have 1 million tokens or 750K words, right? How do you even break it down? How do you see what is where, right? So give it trajectory and ordering issues, right? And observability kind of thing, that, and debugging, right? If something goes wrong, who was able to access what? Some compliance issues, essentially, right? Because if somebody was able to pull off data from sources which were not supposed to be used, right? Say it's US versus Europe versus Asia, right? You want to pull it out, right? You don't want to. There's some access policies, right? So if you you have to stick to that particular governance model, right? And privacy issues, latency, system limits, all these are like the multiple, right? We can go into them one by one, right?
Gotcha. So there are some architectural challenges with the approach, and there are architectural benefits as well. So maybe one of the benefits is the less reliance on things like RAG or pulling additional context information in at inference time to include. You can include more information in one shot, but that comes with things like regulatory compliance concerns. It comes with other concerns. Is that
Right.
what I'm hearing?
Yes. Yes,
Now,
exactly. Yeah.
now, what's useful in a large context window? What can we do now with a larger context window more accurately than we could do before, even by chunking?
So, okay, it's a good question. Now we have, since you can put all these different things into single, fit more context into more words or more tokens into single request, you have you can show it more, right? Instead of chunking, and because chunking also led to chunking shift or context drift, they call it before, right? Because you have to remember your chunk it and remember and have to have context from the first request to the next one. So you go one by one, right? So cross document reasoning is possible, right? Because previously that was an issue because you could do it, but it had all the issues that we had seen before, right? With this one, at least now you have chunking would only see a few fragments at once, but with this one you can see to show the whole document, right? You can say compare all 40 vendor contracts, for example, right? And then give me and towards some template, right? Before this whole thing large window came into picture, it was, you had to chunk it, and then you'll always have drifts there and that kind of thing. So second is narrative can be more cohesive now, right? Right, it's more cohesive and right, because every entire chunk on manuals are intact now, right? The model understands sequences, caveats also, and cross-referencing, right? That's right. And I think that's the start of this.
So if go ahead, Lori.
I was going to say, this feels very similar to the early web evolution where, right, at first sessions were passed back and forth. They were stuffed into cookies, into URLs. I mean, they would put them anywhere until they figured out how to get more persistent sessions and store that. And that sounds a lot like context being shared, but now either the model, or I should say the inference server, can actually maintain a million tokens of that, or use external systems like databases of some sort to actually persist that longer over time, which of course there are risks, but there are also advantages in how you might build new applications or leverage that in your enterprise.
Right. Yeah, I think you think back early days of, as you just mentioned, right, of the web, right? HTTP was stateless. Every request forgot what came before that, right? Now developers invented sessions and cookies, as you mentioned. Yeah, so that seems very similar to that approach. Yeah.
Yeah.
Now we have bigger ones. Yeah, that's right. Yeah.
Now, when I think of what enterprises develop over the years that increases measurably in size year over year and could present an interesting analysis task for something with a large context window, my mind, because I'm an engineer, immediately goes to code bases of legacy applications. So, what benefits does a very large context window have for either code generation or conversion of existing legacy code bases to new programming languages, for example?
Yeah, it's a very deep question. Okay, so again, I think before we go into advantages, you have to remember that compliance issues, right? If I'm
Oh,
an engineer, I
absolutely.
have to write.
Yeah.
You give me something to do. I'll say, okay, you'll give me this task now. Okay, I'll put all this database and the Git, push it to LLM, and let it answer all the questions. I can have tea there and come back, whatever, right? The answer will be ready, right? So that's kind of a typical approach people will do, right? I personally will do, right?
Right.
But we know that's simple, but it's not going to work, right? It will have other side effects, right? Now, so now, in terms of now, going back to your question, right? So the benefits of this, right? Now, before the whole code of visibility is there now with this new scheme that we have. Before you could only fit small files or snippets. The model would lose track of cross-file referencing again, right? Now we have one single thing. Large context lets you drop an entire module or even whole repo into this large into the model, right? Preserving structure and preserve dependency, right? That's kind of what it is, right?
Yeah.
And so the benefit of that was, the model can generate and refactor code with awareness of entire system, not just isolated pieces of the code or functions, right? So this is a more cohesive picture there, right? So second is again cross language conversion with text with context, right? Because now it knows that, before translating code bases chunks into often led to mismatched APIs or lost business context logic there, right? But with this one, it can see more context, more this thing, so it's basically better. Even tools can connect to AI models into the code base. That's another thing we are seeing nowadays. The tools can connect to code base ideas and even commit directly to GitHub. Basically, you give me something to do, I'll connect to some kind of other model, will do all the magic. So convert from this language to this language, Python to C, whatever that is, right? And then commit to this other, right? So that's benefit of that, right? So I think,
and I appreciate you bringing up the challenges of that particular approach before we talk about the benefits, because a lot of times when people are uploading things for inferencing into these models, they consider the benefits first and the challenges only after something bad happens. And so,
exactly,
there are absolutely risks when you take your entire private code base and upload it effectively to these models. And one should certainly consider the challenges and possibilities of that ahead of the benefits is I think what you're saying.
We should probably recommend against uploading your entire code base to a public AI anything, because one, that's probably going to break company policy besides just being a bad idea. But if you wouldn't upload it to a Google Doc, don't put it in a public AI. Like, that should be the rule.
Yeah.
And
exactly.
another thing to add to what Laurie said, right? So you can also, supposing I'm going to upload this whole code or whatever document, right? There should be some kind of meter there. Okay, this document is so big, this is going to take this long, and it's for token cost, because it's not going to be free, right? This is kind of a telling the user or engineer, okay, this is going to upload is fine, but this is again, and that's one thing. Other thing is, if you're going to do it, give a trajectory, right? I think that is a beautiful concept they've introduced now. The trajectory of whole conversion, that you just don't dump the code, and you stay the trajectory there, right? That summarize architecture, translate core modules, refactor patterns, all these things, right? So it's kind of, I think if I were to do it, I would do it that way, right? Rather than
I think that's an important point that you just made there, that the tokens still have cost, right? So just because you can upload things and have more tokens considered in one shot of context, those tokens still cost the same. Right. So it can consume more, but it will still cost you just as much as it would if you were chunking it and inputting all that data and managing the context windows yourself.
Well,
So
isn't that the one of the benefits of building out your own AI applications to leverage it is that you can actually inject things like, hey, you're trying to upload something that's going to cost, this much money and well, your budget doesn't allow for that, so let's cut it down. Those kind of functionalities you can embed in that you don't get if you just go to Chat GPT, which happily accepts any size, of course, especially if you're on an enterprise plan and paying by the token.
mm, yeah. Now, is there anything else that people need to take into account with the availability of ever larger context windows? And secondarily, do you think that the context window element of these foundational models, is this becoming kind of a race between models to provide ever larger context windows?
Yeah, I think so. I think one thing I like to add is that a million token context sounds amazing. You can feed the whole document or code base into this, right? Uh, but again, you have to be careful of, one mindful of what you're going to do there, right? One is always privacy issues,
Hmm.
governance issues, and or I think one thing I really didn't bring up was audits, right? And who, and also explainability, right? If you are converting, say, code to something, right, or some kind of document reference, it's Q&A kind of thing, right? You should be able to cite where it came from, because often I think I've seen that it'll pick, there's a positional bias there, right? It's something in the, supposing I ask you a question, what is the uh, some kind of, say, what is say, it'll always pick the first position, like whatever answer comes first, it'll pick that one. Suppose something is the appendix much below there, that will be forgotten, right? Or basically something in the middle will not be considered that much as compared to something in the first and the last part of it, right? So that's one thing that I've seen, that and it's kind of the context decay, or I think they call it recency bias, right? Essentially
Hmm.
that even the huge window models often forget early content, right? So I think that's another thing that you have to worry about here, right? Cost quality trade-off, diminishing rate. Again, beyond certain point, I think what I've seen is, or read is, that about 200, 300 tokens, added token context may not lead to much gain, right? Again, from what
Right.
my personal experience, I don't know, right? We can with different answers there, but right. And persistent needed for RAG now, right? Because RAG remains valuable even large context windows, right? Right, because context windows will have finite limits, no matter how 1 million, 2 million, 10 million, but have some limit always, right? So we still need RAG there, right? RAG supports real-time updates, audit trails. RAG helps
Yeah.
again and to target more self information, not just
Right.
biggest dump, right? So
One final question before we talk about what we learned today. If you put your prediction hat on, Vishal, and you think about models that are going to be available 5 years from now, how large of a context window is a model 5 years from now going to have, do you think?
it's a tough one. So we started about 3 years ago, I would say, when the whole race started. We came from like 1K when I started all this. We started using all this to like 1 million in 3 years,
Hmm.
right? And we all learned and matured over time. Now let's see, right? So we started from zero to like whatever what scale we are at, right? So
Gotcha.
certainly multi-million. Hard to pick a limit. Maybe 5 to 10 million. Because finally there'll be diminishing returns, right? You can put everything there, but no, it's more about, I think, giving it trajectory. I think that's basically, you fine, you can have much larger window, but you can have whole code base. But given the geometric growth from 4K to 1K to 4K,
Hmm.
for this one, these sizes would enable AI to process entire books and all. Large capacity. The thing is, the architecture advances, right? Like sparse memory layers, expert models are becoming production grade now, right?
Yeah.
So I think if I if you ask me for a number, about 5 to 10 million, I think.
Oh,
After
okay.
that, I don't know, right? So
All
it's
right. Well,
where I think
I
we'll
for
go.
one look forward to my 1 billion token context windows in the near future. One of the things that I learned today is about the race to the ever larger context window. I think that this is being considered competitively to be an advantage from one model to offer to another. So I noted quite dramatically that GPT-5 has a larger context window than 4.1 did. And I think that this is definitely being considered as something competitive by the model providers. I also learned that you still need to take into account all of the challenges of inputting large amounts of data into these models. What about you, Lori?
I learned that bigger is better when it comes to actually getting accurate answers from AI. So bigger context windows are leading to better accuracy, but it's also going to cost you, and that there are a lot of privacy and compliance and governance sticky issues that you can run into by oversharing. And maybe big context windows encourage oversharing. I didn't learn, but I think I learned something I want to dig into, which is how that 1 million token window actually translates into memory and resources needed. Because as those grow, that means that the inference server can actually handle less and less, it sounds like. And I think that's a scale issue in an architecture. So enterprises are going to struggle building these out if they have context windows too big. So maybe that's a tunable knob for enterprises as they're building out applications.
True. And then finally, in my opinion, winners of this race will be finally those who shape trajectories, right? Because who decide what goes on in the model path. Everything is logged, explained, because at the end, governance, cost, orchestration of all this, and trust of all the flows. It's one simple question that, what path do we want to model to work with, right? And I think that's kind of the thing, right? Just not window, but things around that, right? Trajectory and all these things, right? Compliance. We'll finally decide who wins this race, I think, in my opinion.
Excellent.
Awesome. Wow. That is a wrap for Pop Goes the Stack. Follow the show so you're on call for our next forensic adventure. Until then, sleep with one eye on the logs and the other on the subscribe button.